Good evening, grade 9s. I hope that the sound comes out okay. I'm recording straight onto the iPad for this one. I'm going to go through the questions that at least one person had and just skip through to the questions that you want help with. So I'm starting off with question 1. And what we have to do here is distribute. So we're saying minus 2x times 2x squared. And so minus 2 times 2 is minus 4. And x times x squared is x cubed, because we're adding exponents and x is x to the power of 1. And then we can do the same for minus 2x times positive 3x. And we've got minus 2 times plus 3 at least is minus 6. And x times x, again, this is x to the power of 1, so x times x is x squared. And finally, minus 2x times minus 4, and we've got minus 2 times minus 4 is positive 8, and we've got an x over there. Right, moving on to question 2. We've got a binomial times a binomial. In other words, 2 terms in the first bracket, 2 terms in the second bracket. We need to multiply every term in the first bracket by every term in the second bracket. So let's start with 3x times 3x gives us 9x squared. Then next up we've got 3x times 4y, which gives us positive 12xy. Then we've got minus 4y times 3x gives us minus 12xy. And finally, minus 4y times positive 4y gives you minus 16y squared. These two terms in the middle are like terms, so we can add them. So 12xy minus 12xy actually just gives us 0. So our final answer is 9x squared minus, don't do that, minus 16y squared. I've written that terribly, so let's rub that out and write it a little bit nicer. Minus 16y squared. And you may pick up that that's a difference of 2 squares, so you can go straight to that if you can. Question 4 is very similar to question 2. We've got a binomial times a binomial, so multiply every term in the first bracket by every term in the second bracket. So 2x times x is 2x squared. 2x times 5 is 10x. Minus 2 times x is minus 2x. And minus 2 times positive 5 is minus 10. These two terms in the middle are like terms, so we need to add them. So if we do plus 10x minus 2x gives us plus 8x. Next up we got question 5, and if we're squaring something, it means you multiply it by itself. So let's rewrite this as 4 plus 1 over x times 4 plus 1 over x. So we can see what we're doing. Now it looks like question 2 and question 4. Multiply every term in the first bracket by every term in the second bracket. So 4 times 4 is 16. Not too bad so far. 4 times 1 over x. Let's just do a little bit of working out on the side here. And we've got 4 times 1 over x. Well, 4 is the same as 4 over 1. So if we do write that as 4 over 1, now we've got a fraction times a fraction. And that's easy, because you multiply numerator times numerator. 4 times 1 is 4, and 1 times x is x. So we've got plus 4 over x. Now it's going to be very similar when we multiply 1 over x by 4. We've got 1 over x times by 4, and let's write 4 is 4 over 1. So we've got 1 times 4 is 4, x times 1 is x, so plus 4 over x. And finally, 1 over x times 1 over x, well, same strategy. 1 over x times 1 over x, multiply numerators, multiply denominators, plus 1 over x squared. Now, these middle terms, again, are like terms. Middle terms, I mean 4 over x and 4 over x. So we've got the same denominator, so we can just add our numerators together and say, quite simply, we've got 8 over x. Moving on to question 6, we just need to distribute our minus 5x times by each one of these. The first bit's not too bad. Minus 5x times 1 is just minus 5x, but perhaps it's the second bit that's tripped people up, and I'm going to do it in a bit of working on the bottom here and say minus 5x times 5 over x. And if you've watched question 5 before this, you'll probably know the strategy, which is just write each of them as a fraction. Now we can multiply numerator times numerator, gives you minus 25x. denominator times denominator 1 times x is x, and we can now cancel. Now x goes into those ones, so we're left with minus 25. Yes, at this stage you could have gone minus 5x over 1 times 5 over x, cancel these x's straight up here, and gone straight to minus 25. For question 7, the best way to do this is to factorize your numerator and factorize your denominator. Do not be tempted to just cancel those two x squareds. So we've got in our numerator, what's our highest common factor? It's x squared, and x squared times what gives us x cubed? Well, times x. X squared times what gives us 2x squared, plus 2, our denominator is still x squared. Now we can quite merrily cancel these x squareds, and we're left just with x plus 2. Question 8, and clearly we need to keep on practicing our factorization. 3 different options for factorization. Highest common factor, always the first thing you check. Then, is it difference of 2 squares, or is it a trinomial? Trinomial has 3 terms, like a tricycle has 3 wheels. So, highest common factor for question 8. Highest common factor is 1. Not too interesting. Definitely not difference of 2 squareds. Definitely is a trinomial because there are 3 terms over there. X squared, minus 4x, and minus 21. So let's factorize it into 2 brackets. The first term in each bracket, when you multiply it together, is going to give you x squared. Well, x times x gives you x squared. The second term in each bracket, when you multiply it together, is going to give you minus 21. Now, there are going to be a few options here. I'm going to jump straight to the correct answer. And that is, well, 7 times 3 gives you 21. Now, we need it to equal minus 21. So it's either going to be minus 7 times by positive 3, because that gives you 21. And for our middle term, minus 4x. Just focus on the minus 4 in front of the x. Does minus 7 plus positive 3, does that equal minus 4 is our question. If it does, then we're in for a winner. Well, minus 7 plus 3 is indeed minus 4. So, minus 7 plus 3. So, to run through it again quickly, minus 7 times positive 3 gives you minus 21. Minus 7 plus 3 gives you minus 4, the middle term. Right, okay, question 9. We've got factorization. So on the bottom here, we've still got 3 options. Highest common factor is 1, so not too interesting. Difference of 2 squareds. Yes, it is. X squared is a square number. 9 is a square number. So for difference of 2 squareds, we break it down into 2 brackets. First thing we look at is the x squared. What is the square root of x squared? Well, it's x, so x and x. What's the square root of 9? It's 3. So 3 in each bracket, change sign in each bracket. Plus minus. If you multiply this out, you can do it to check for yourself. It will give you x squared minus 9. Question 10. We've got factorization once again, and let's run through it. Highest common factor, dots, trinomial. Highest common factor. Yes, there is a highest common factor. We can take a minus 9x out of here, and we're left with what? Minus 9x times what gives you minus 9x squared? Well, we just need to multiply it by x. Minus 9x times what gives you minus 27x? Well, just times plus 3. You could check by distributive law that minus 9x times x gives you minus 9x squared. Minus 9x times positive 3 gives you minus 27. Some of you might ask, what happens if you took positive 9x out? That would be fine. In your brackets, you'd have minus x minus 3. Generally, however, you take out the negative, so you're left with a positive x in the bracket. Either way is going to get you the marks. Either way is correct, because we don't know what we're using this for at the moment. Okay, question 11. And what surprises me is that very few people ask for question 8, but lots of people have asked for question 11. We're doing the same thing here. We need to factorize, and let's run through our things that are on the bottom right. Highest common factor, it's 1. Not too interesting. It's not difference of 2 squareds, it's a trinomial, 3 terms, like a tricycle. So, let's go down. Bracket, wrong type of thing. Let's go bracket, bracket, that's a terrible bracket, bracket, bracket. What times what gives you x squared? Well, x times x. What times what gives you 16? Well, I'm going to go straight to the right answer. I know that it's 4. Either it has to be negative 4 times negative 4, because that gives you positive 16, or positive 4 times positive 4, which gives you 16. So let's say we choose minus 4 in each bracket. Then minus 4 times minus 4 gives you the positive 16 at the end. Great stuff. What's minus 4? And we add minus 4 to it. Let's simplify this. Minus 4 minus 4. Well, this gives you minus 8. In other words, if you add the two minus 4s, you get minus 8, which is our middle term. So minus 4 minus 4. You can write this as they do in the memo, and it is nicer to write it this way rather than writing it as x minus 4, x minus 4. You can write it as x minus 4 squared, because that's just a much more compact way of writing it. Factorization continues with question 12. And let's go through. Highest common factor. Nope, nothing too interesting there. 1 is our highest common factor, I guess. Difference of 2 squareds. Oh, yes, look at these nice square numbers. 36, x squared, 64. These are all lovely square numbers. So difference of 2 squares looks very similar to question 9. Bracket, bracket. And our first term, when multiplied together, is going to give us 36x squared. So what times what gives you 36? 6. What times what gives you x squared? X. Okay, for our second term, let's look at our fraction, 1 over 64. Well, the numerator times the numerator is going to give you 1. Well, 1 times 1 gives you 1, so 1. What times what gives you 64? With a bit of luck, we know that 8 times 8 gives us 64, and then we just go plus and minus. Okay, I'm going to run through question 13 quite quickly because it's a bit of a silly question, really. Highest common factor is 1, so not too interesting. Difference of 2 squareds, it's not difference of 2 squareds because it's not a difference, it's an addition. So it's not difference of 2 squareds. Trinomial, no, trinomial is 3 terms, like a tricycle has 3 wheels. This is a binomial, like a bicycle with 2 terms. So we can't factorize. In other words, it stays as x plus 1. So yeah, silly question, really. Question 14. Okay, highest common factor is 1, not difference of 2 squareds. Yes, we're looking at our good old friend, the trinomial, which we factorize into a binomial times a binomial. X times x gives you x squared. Factors of 42, such that when you multiply them, you get 42, and when you add them, you get minus 1, because this is minus 1x. So we've got 6 and 7 sounds reasonable. 6 times 7 gives you 42. And if we go plus 6 times minus 7, we get minus 42. And if we go plus 6 plus minus 7, we get minus 1, our middle term. So there we are. If you jump straight to this question, go back to question 11 and question 8, which have a more detailed explanation of factorizing trinomials. Okay, question 15, which had the most requests out of all of the questions, and I can understand why. The exponents suddenly changed the game a little bit. We're still looking at highest common factor, difference of 2 squareds, or trinomial. Let's rule out difference of 2 squareds because it's an addition, not a difference, plus not a minus. And it's not a trinomial because they're 2 terms, so we must be dealing with highest common factor. Now this will probably give the game away somewhat, but let's use our exponent laws. Let's use the one that says a to the m times a to the n equals a to the m plus n. In other words, if you're multiplying with the same base, then you add exponents. But let's do this from right to left. We've got a to the x plus 1. So instead of m plus n over here, we've got x plus 1. And therefore, instead of m and n over here, we've got x and 1. So in other words, instead of a to the x plus 1, we can rewrite this as a to the x times a to the power of 1. The dot in the middle just means times. And a to the 1 is the same as a, but let's leave it as a to the 1 plus a to the x. These two are equal to each other. Now, staring us in the face, what's our highest common factor? Well, we can take an a to the x out. And what do we multiply a to the x by to get a to the x times a to the 1? Well, a to the power of 1. Or a, same thing. What do we multiply a to the x by to get a to the x? Well, just 1. Easy when you know how? Hopefully when you practice this and the next time and the next time and the next time, you'll get them. The exponent ones are a bit more tricky than our straight up algebra from the previous questions. Good evening, grade 9s, and welcome to another exciting episode of your skills exam. Okay, so for question 32, we've got x cubed divided by x to the 7, and we subtract exponents. So the general rule says x to the p divided by x to the q equals x to the p minus q. In other words, take the top one and minus the bottom one. So in this case, we've got x cubed divided by x to the 7. Well, it's x to the 3 minus 7 gives us x to the minus 4. However, we need to give this in positive exponent form. So we need to use another of our algebra or exponent rules, which says that x to the minus p is just the same as 1 over x to the p. So in this case, x to the minus 4 is just the same as 1 over x to the 4, which is our final answer. Question 35, we just need to use our first exponent law that says if we're multiplying and our bases are the same, then all we need to do is add exponents. So in this case, x to the minus 5 times x to the 4. The bases are the same, they're both x. So we can add minus 4 plus 4 gives you minus 1. Now we use our exponent rule that says if we've got something to a negative power, then it's just 1 over that to the positive power. So x to the minus 1 is just the same as 1 over x. 1 over x. Question 36, we're going to use the rule that says a times b to the power of p is just a to the p, b to the p. In other words, apply the exponent to each of the numbers and variables in here. So we're going to say, what is 2, and we're going to cube that. Well, that's just 2 cubed, which is 8. What is x to the power of 4 cubed? And we're going to use the exponent law that says if we've got something to the power and raised to another power, then that's the same as multiplying. In other words, we just multiply the exponent. So 4 times 3 is 12. So we've got x to the 12, and y squared cubed is just y to the 6, and we're done. Question 37 looks a bit trickier than it really should be, because all we're looking at is saying, well, we've got like terms. We've got x4s, and we've got 7x4s minus 3x4s. How many x4s do we have? Well, we've got 7 minus 3 of them. We've got 4x4s. Question 38, let's look at it in two ways. Let's just apply our exponent law to start with. And that is, if you take the nth power of a to the m, then you just divide a to the m over n. So in this case, we're taking the square root of x to the 8. So it's just x to the 8 divided by 2, which is x to the 4. Great stuff, x4. But let's now just look at it in another way and say the square root of x to the 8. In other words, what when you multiply it by itself gives you x to the 8. So what when we square it gives us x to the 8. And, well, if we took what times 2 would give us 8? Well, 4 times 2 gives us 8. Therefore, the square root of x to the 8 is x to the 4. Or we could think of this as, well, what times itself gives you x to the 8? And if we're multiplying and the bases are the same, we need to add. So what plus itself gives you 8, which is another way of saying what times 2 gives you 8, x to the 4. All valid ways of answering this question. Question 39, and this is where I'm expecting huge viewership numbers because a lot of you asked for this. And it is a bit of a tricky question. Let's have our order of operations down the side here. Brackets, exponents, division and multiplication, these actually go together, and addition and subtraction go together. Brackets, what that means is there anything within the brackets we can simplify? No, x squared is x squared, so there's nothing we can do within that. So we've done what we can in the brackets. Exponent, do we have an exponent? Yes, we do. We've got a minus 2, and it applies to what comes before it, so what's in the bracket, so the x squared part. So this equals the minus, still comes down here, minus whatever we get here. Well, x squared to the power of minus 2, we apply our exponent law that says, well, when you raise a power to a power, you multiply. So you've got x to the minus 4. Okay, so we're good so far, except we need to put this into positive exponents. We don't need to turn the number into positive, just the exponent part. This part here needs to be positive. So let's think of this as minus 1x to the power of minus 4, because we've got minus 1 of them. So it's the same thing. And how do we convert x to the minus 4 into a positive exponent? Well, that's x to the power of 4. And watch the videos just before this, or the clips just before this, to see that rule. So if that part here is 1 over x to the 4, then we got minus 1 of these 1 over x to the 4s, which means we've got minus 1 of them, minus 1 over x to the 4. Notice that the whole thing is still negative. We haven't changed the sign. We haven't suddenly turned minus 2 into 2. All we've done is rewrite it so that it's to a positive exponent. So we've got minus 1 over x to the 4. Watch this video again if you need to, and do a few more practice papers just focusing on that question if that's one you're struggling with, and go through that procedure of we're doing this order of operations. So start with your brackets, probably won't be anything you can simplify within the bracket, then do your exponent and multiply it in, and then use your exponent law to say that x to the minus p is just the same as 1 over x to the p. So in this case, like x to the minus 4 was 1 over x to the 4. And in this case, it was a negative of that. So hopefully that helps a little bit. Question 43, and we're adding fractions. And when we add fractions, we need to make sure that our denominators are the same. Well, they're not, 8 and 4. So let's find our lowest common denominator. And our lowest common denominator is 8. So 7 over 8 stays as 7 over 8. How do we change 2 over 4 to 7 over 8, to something over 8? And we've multiplied 4 by 2, so let's do the same to our numerator. So we've got plus 4 over 8. And let's add those. 7 plus 4 equals 11, and it's still over 8. Don't worry about changing it into a mixed fraction. It doesn't ask for that. That is as simple as 1 and 3/8. They're really the same thing. From adding to multiplying, when we multiply fractions, all we need to do is multiply numerators. So we've got 6 times 5 is 30, and multiply denominators. 8 times 8 is 64. Ooh, not quite simplest form. Let's divide by 2, 15 over 32. That seems like it's in its simplest form. Question 45, and this is where my viewership numbers soar through the roof, and I put my advertising here, right? Okay, so for this question, we need to think back to prime factorization. In other words, write this as a product of prime numbers. So let's start with our numerator. And on the right-hand side, I'm going to show a bit of working. So 25 is the same as 5 times 5. 5 and 5 are prime numbers, so that's as good as we can do. 5 times 5. 49, so we've sorted out this one. 49 is 7 times 7. Great stuff, those are prime numbers, so times 7 times 7. 490. Let's break this down. So 490 equals 49 times 10. We're not at prime numbers yet. Let's start with 49. Well, we've just done it. 49 is the same as 7 times 7, and 10 is the same as 5 times 2. Okay, so we've got 7 times 7 times 5 times 2. Now, let's cancel away where we can, because we've got one term on top. There are no pluses or minuses between the terms, and one term on the bottom. There are no pluses or minuses between the numbers. So let's go merrily away. 5, 5, 7, 7, another 7 and a 7. So all we're left with is a 5 and a 2. So 5 over 2. And that's really how you do that type of question, prime factorization. And break it up. So this 490, we didn't go straight to 7 times 7 times 5 times 2. We got there in a couple of steps. And we move on to scientific notation. Now, instead of just moving this comma and then saying, oh, what is the answer? Let's just do this in steps to see why we would do that. 3,700. Well, what happens if we said, well, that's the same as 370 times 10? Okay, that seems reasonable. Well, in scientific notation, this first number needs to be between 1 and 10. So let's do it again. 37 times 10. That's the same as 370. But don't forget that we still need to multiply that by 10. Well, from exponents, we know that 10 times 10 is the same as 10 squared. So we got 37 times 10 squared. Well, 37 isn't between 1 and 10. So let's say 37 is the same as 3,7 times 10. That seems reasonable. Oh, but we're still multiplied by 10 squared. Again, exponents tell us that 10 times 10 squared is the same as 10 cubed. So we've got 3.7, that's the same, times 10 cubed. But how can we get there quickly in one step? Well, our decimal point is sitting here. So we can just count it and go, well, let's move it left. 1, 2, 3. So if we've got it here, we've got 3,7 times 10 to the power of 3. Which kind of makes sense. 3,7 times 10 to the 3 is 1,000. So 3,7 times 1,000 is 3,700. Poor scientific notation not being called an ordinary number. Oh, well, maybe it's extraordinary. So we're trying to convert this number into non-scientific notation. And we've got minus 1.46 times 10 squared. And just think about this for a second. Of 10 squared is 100. So we've got 1 comma something times 100. So we should probably get 146. And let's again do this by not just moving the decimal comma. I've got inverted commas, air quotes here. But minus 1.46, we need to times by 100. Well, let's times it by 10 first and then by 10 again. Because 10 times 10 is the same as 10 squared. Well, that's the same as, well, minus 1.46 times 10 is minus 14,6. So that accounts for this bit here. And let's not forget to multiply that by 10. Because multiplying by 10 is easy. All we do is say, well, minus 14.6 times 10 is minus 146. And that's it. We don't have to multiply it by 10. That fits in with what we were saying at the beginning, that we're multiplying 1 point something times 100, or 1 times 100 is 100, and 2 times 100 is 200, so we're somewhere in between 100 and 200. Let's now do it by, air quotes, moving the decimal comma, and that is, we've got a 2 over here, so let's say 1, 2, it's over here, so we're left with minus 1, 4, 6. Okay, there's a little bit of work sometimes to be done on these. In this case, actually not too much work. 6 times 10 to the 8 plus 2 times 10 to the 8. So we've got 6 of these 10 to the 8s, and we're adding 2 of them. So how many of them do we have? Well, we've got 8 of them. Think of this, if you want to, as 10 to the 8, think of that as like the variable a, or the variable x. We've got 6 of these a's and we're adding 2 of them. Or we've got 6 of these x's and we're adding 2 of them. How many of them do we have? Well, we've got 8 of them. So we've got 8 of them being 10 to the 8s here. Our friends' patterns from today. I'm recording this on the Thursday. And we've got 5 minus 1 minus 7 minus 13. Write down the general term. Well, what is our constant difference here? To get from 5 to minus 1, we have subtracted 6. To get from minus 1 to minus 7, we've subtracted 6. And every time we subtract 6. So our Tn is minus 6 times n. Now let's check for our first term. If it were just minus 6n, then we'd say minus 6 times 1 for our first term is minus 6. But that's not quite right, because our first term is actually 5. So to get from minus 6 to 5, we need to add, well, let's add 11. Let's check if that works for the second term. So for our second term, if we say that our rule is minus 6n plus 11, then we should say minus 6 times 2 plus 11 should give us our second term, should give us minus 1. So minus 6 times 2 is minus 12. Minus 12 plus 11. Hey, that works out quite nicely. So yeah, minus 6n plus 11. The minus 6 coming from the constant difference, and then the plus 11 to get us where we need to be. Okay, that was question 61. On question 62 now, write down the 20th term, t20. So we've got tn equals minus 6n plus 11. Now in this case, let's just, for those that this helps, look at our input and our output. Our input is n and our output is tn. So think of this in terms of functions as x and y. So when we input n, we get minus 6n plus 11. So now what we need to find out is when our input is 20, what is our output? In other words, what's t20? So instead of n being n is now 20. So let's rewrite this same equation, but wherever we see an n, let's put a 20. So we got minus 6 times 20 plus 11. Minus 6 times 20, well, minus 6 times 2 is minus 12, so minus 6 times 20 is minus 120, plus 11, and that's going to give you minus 109, minus 109. Okay, onwards, upwards, and we're on question 63. Now, if we look at our diagram we had here earlier, and expand these bubbles just a bit more, so we got bit more space. In this case, we're given what the output is. Which one is equal to 169? And let's try and figure out what is our input for this here. So we've got our general form is tn equals minus 6n plus 11. And let's replace the bits we know. We know what tn, we know what the output is. We know that it's at minus 169. Minus 6 times, we don't know what n is, so let's leave it as n. And we've now got an equation. And to solve this, let's subtract 11 from each side. And we've got minus 180 equals minus 6n. Divide each side by minus 6. So that on the right-hand side, we've just got n. And on the left-hand side, minus 180 divided by minus 6 is going to be positive 30. In other words, the 30th term in our sequence is 30. So is 100 and minus 169. So if you went 5 minus 1 minus 7 minus 13 and kept going all the way up to the 30th term, the 30th one would be minus 169. Question 64, and this is going to be a little bit involved, definitely take more than a minute to do. We've got a function, and I'm going to redraw this function just in terms of our Easter eggs. It's the same thing. We've got our input as x and our output as y. So when we input minus 4, we output 12, etc. Minus 2, our output is 8. And this applies for all of them, which I'm just going to quickly put in. There we go. So our function, I think what we know for the skills paper is that it's going to be a straight line type of function. When you're not going to get given an x squared or something funny like that. So we can think our equation is going to be of the form y equals mx plus c. A straight line, that's our standard form. Where m represents our gradient. Now you don't have to write this all down when you're working it out, you can do it in your head. But our gradient is rise over run. So let's take an example pair. Let's take this pair over here. Our first input is 2 and our second input is 4. So in other words, we've run from 2 to 4. How far have we run? We've run 2. To get from 2 to 4, we've added 2. Let's look at our output. We've risen from 0 to minus 4. So how much have we risen? We've risen minus 4. So our gradient is minus 2. So far we've got y equals minus 2x plus c. We don't know what c is, but we can use any one of these points. And I think the easiest point I'm going to point out in the diagram up here is, let's choose this one here. It's got a 0, so it's going to make our lives easy. So now we've got, if y equals minus 2x plus c, well, our y in this case, our output is 0. Our input is 2, so minus 2 times our input, 2, plus c. 0 equals minus 4 plus c. Let's add 4 to each side of our equation, and we've got 4 equals c. Great stuff. That means we've got our equation, y equals minus 2x plus 4. I'll leave it to you to check that it works for all the inputs. If we input minus 4, is our output 12? If we input 4, is our output minus 4, etc.